Imagine a world without the number zero. Seems impossible, right? Now let's journey back in time when zero wasn't even a thought in the minds of mathematicians. Ancient civilizations developed their own number systems, like the Egyptian hieroglyphs, Roman numerals, and the Babylonian cuneiform. But none of these systems had a concept for zero or the decimal system. These ancient number systems were unique, but they had their limitations. Picture trying to do complex calculations with Roman numerals. It would be like trying to solve a puzzle with missing pieces. The absence of zero and a decimal system made tasks like multiplication and division a real chore. The world needed a better way to crunch numbers, a system that would simplify calculations and expand the boundaries of mathematics. Enter the mighty zero and the versatile decimal. Little did the world know that these two humble characters would revolutionize the field of mathematics. Without zero and decimals, mathematics as we know it would be vastly different. The revolutionary concepts of zero and decimal didn't just appear out of nowhere. Our journey begins in the cradle of civilization, ancient Sumer. Sumerians, around the 4th millennium BC, first used a symbol to represent zero, but merely as a placeholder in their sexagesimal number system. It was a way to differentiate between, say, 1 and 60, but the concept of zero as we know it today was still a far cry. Fast forward to the 5th century AD, in the vibrant intellectual hubs of India. Indian mathematicians were working on something groundbreaking. The concept of zero was beginning to take shape beyond just a placeholder. Brahmagupta, a scholar and mathematician of his time, wrote a text where he defined zero for the first time and presented rules for arithmetic involving zero and negative numbers. However, it was Aryabhata who took a step further and treated zero as a number in its own right, a concept that would revolutionize mathematics. Meanwhile, as the concept of zero was being refined, another significant development was taking place. The decimal number system, a system that is so integral to our daily lives today, was being born. This system, based on powers of 10, provided a more efficient and versatile way of dealing with numbers. It allowed for easier calculation and opened up new possibilities in mathematical exploration. And it wasn't just the Indian mathematicians who were in on this. The decimal system was being developed concurrently in places as far-flung as China and the Islamic world. This was truly a global effort, a testament to the universal language that is mathematics. The birth of zero and decimal marked a turning point in the history of mathematics. These concepts, born out of the intellectual curiosity of our ancestors, have shaped the way we understand and manipulate the world around us. They are fundamental to everything from basic arithmetic to complex algorithms that drive the digital world we live in today. So, zero and decimal were discovered, but why does it matter, you may ask? Well, the impact of these two mathematical concepts is far-reaching, fundamentally changing how we understand and interact with the world. Let's consider zero first. You see, zero is not just a number. It's a concept, a cornerstone of our digital world. It's the heartbeat of binary code, the language of computers. With just 2 digits, 0 and 1, we can create a universe of information, from the words you read online to the videos you watch on your devices. Without zero, our digital age would simply not exist. Now let's turn our attention to the decimal system. This ingenious system of counting based on tens has made complex calculations more accessible to everyone. It's the language of commerce, science, and everyday life. From grocery store receipts to rocket science equations, the decimal system simplifies the complex and makes the abstract tangible. Without it, even the most basic calculations would become a Herculean task. But the influence of zero and decimal doesn't stop there. They've helped shape fields as diverse as astronomy and physics. With zero representing the absence of a value and decimals allowing for precise measurements, scientists can model the cosmos, calculate the speed of light, and explore the smallest particles of matter. In computer science, zero and decimal are equally essential. They underpin algorithms, data structures, and the very logic of programming. Without them, we wouldn't have the advanced technology that shapes our modern lives. In a nutshell, zero and decimal are more than just numbers. They are the bedrock of our understanding of the universe, the tools we use to measure, calculate, and comprehend the world around us. They have made the complex simple, the unreachable attainable, and the unthinkable possible. From powering our computers to helping us explore the universe, zero and decimal have truly revolutionized the world.